Hello everyone, today we're going to solve this problem that is write a valence equation for the given chemical reaction. Is this one, that is the photosynthesis reaction. So first, we're going to assign values to these equations. We're going to assign x1 here, x2 here, because it's another equation, x3 here, and x4 here. We're gonna have here the left, that is x1 and x2, and here the right. Left side and right side. Here we're gonna assign CHO. Here we have 1C, so it's x1. In this equation we don't have an H, but in x2 yes, so we have 2H for x2. And for oxygen it's 2, so in x1 is 2x1, and also in this equation that is the x2 we have 1 oxygen, so we'll do 2x1 plus x2. And in the right side we have in carbon in x3 6, also we have 12 in H x3 and 6 in oxygen x3, and here we don't have a C, neither an H, but we do with oxygen, so we'll do 6x3 plus 2x4, and we have here a system of equations. We can solve it by doing x1 minus 6x3. We can find this by doing, here we're x1 equals 6x3, so we clear x1 and this pass here with a minus. Then we have 2x2 minus 12x3 based on this equation equals 0, and 2x1 plus x2 minus 6x3 minus 2x4 equals 0. We can pass this to an augmented matrix. So we're going to transpose these equations to a matrix, and we'll do 1, 0, minus 6, because here have x1, 1, in x2 we don't have, so it's 0, x3 is minus 6, and 0 and 0. The next will be 0, 2, minus 12, 0, 0. The next one will be 2, 1, minus 6, minus 2, and 0. And here we have our augmented matrix. So the next step is to do this matrix, this diagonal, once, and this one zeros, and this one zeros, so we can find the solution. Okay, so first we will do this one, a 0, and we can do that by doing in row 3, 2 times row 1 minus row 3. We will get rid of this, making a 0. This will be a minus 1, this will be a minus 6, and this will be a minus a 2 because of the 0. The next step will be making this a 0. So again, row 3, we'll do 2 times row 3 plus row 2. So we get rid of here and make it a 0. Here will be a minus 24, and here will be a 4. Okay, the next step is to do this one a 0 and this one a 0. So we'll do in row 1, 4 times row 1 minus row 3. So will be minus 24, here will be a 0. Here will be a minus 4, and here will be a 4. And the next step is to do here a 0. So we'll do in row 2, 2 times row 2 minus row 3. We'll get rid of this, make it here a 0. Here will be a minus 4, and here will be a 4. Okay, so we have this. Okay, so we have this 0, 0, 0, 0, 0, 0, and the next step is to do here this diagonal a 1. So we'll do row 1, 1 over 4 times row 1. So this will be a 1. This will be a minus 1. In this, we'll do the same. Row 2, 1 over 4, row 2. So this will be a 1, and this will be another minus 1. And in row 3, we'll do 1 over 24 minus times row 3. So we'll get rid of this, making a 1. And here we'll do a minus 1 over 6. Here we have our solution that will be x1 minus x4 equals 0. So x1 equals to x4, x2 equals to x4, and x3 equals to 1/6 times x4. Here our free variable is the x4, so we're gonna assign to x1 a t, x2 again a t because of the x4, x3 a 1/6 t, and x4 a t. Now with this solution, we can solve that problem. So we can here assign values to t, to 1 to infinite, these infinite solutions. So t equals 1, we're gonna experiment with t equals 1. This will be CO2 plus H2O equals 1/6, because x3 equals 1/6 t, C6 H12O6 plus O2. Because in chemistry there is no solution that has a balanced equation with a 1/6 here or a number. We're gonna do t equals 6, so we can assign 6 here, and we'll get rid of this. So it will be 6 times CO2 plus 6 times H2O. Here we'll get rid of this 1 over 6. We'll do C6 H2O6, and here a 6 plus 6O2. This will be our final result to that problem.